okay, what's our dependent variable here whenever we're talking about enzymes? What's the
temperature?
it's all, no, what's the dependent variable? What's on this axis?
Oh, rate of reaction.
Right, so this is rate of reaction.
And then the bottom is whatever.
Okay, so this is dependent, so this means we're measuring this, right? And then what's along the bottom gonna be?
Anything.
It can't be anything because I said we're talking about this.
Oh, the pH level.
pH level. What scale can I have for my pH level?
From 0 to 14.
It can't go below 0 and it can't go above 14. Right? There's no such thing beyond 0 and 14. We don't measure. So if you look at temperature, for example, and pH, or sorry, temperature and enzymes, you could go into the negatives, you could go up to 100, you could probably keep going. It would be really weird because it'd be steam, but you can play around with it a lot. With this is it. Okay, so if we're talking 0, it's very, very
Acidic.
And if we're talking 14, it's very, very
Basic.
Okay. And if we're talking about what would we put in the middle?
7.
Okay, and the 7 is very, very neutral. So we go like 1, 3, 5, 7. Again, they would actually be equal because we were doing this on the graph, and then 9, 11, 13. Okay, so we would measure out our pH, and so what we would do is to do this actual, if we were doing this as an actual lab, we'd make up a bunch of solutions, one of them that's 0, one of them that's 7, one of them that's at 14. It's probably going to be pretty hard for us to get every single other value. We're going to just pick a few. So maybe you pick a 2, maybe you pick a 9, depending on what kind of chemicals you have or what kind of buffers you have. So then we're going to get results, and we're going to like get these numbers and we're going to graph it. So what would the graph look like? So somebody had a picture of a graph. What does it look like when you see an enzyme graph? So this is pH graph.
The rate of reaction would be faster.
So give me an example of how I would draw it.
The curve would be a lot shorter.
Where does it start?
Will it start at 0?
It starts at 0, 0, or not 0, 0. Maybe it starts at like 1, because again, you maybe can't find a 0 acid to start using this with. So it starts at 1, and then what does it do? It rises. It's going up and up and up, and it's not exactly linear, right? And then what happens?
Then you're gonna start to reach the activation complex.
Activation complex is a totally different thing. So just use the other word because it's not activation.
Activation energy?
Nope, it's not activation at all. Maximum point. But what term do we use when we get it to maximum as well? It starts with a P. What do we call it when we reach the max of something? Sometimes we call it a plateau.
Oh, the yeah.
Plateau. Okay, so there's. Pardon?
Plateau means
Plateau means when it straightens out and then it just stays. So you can talk about like, well, this would be this is the maximum. Which you could use like, well, it's where it plateaus, but then it decreases again. Okay, so max. Our rate of reaction here is 0, our rate of reaction here is 0. Now, I think you gave me an example, or sorry, we saw an example for temperature. We also can see an example for where we have 2 different maxes. So this, if we're graphing this though, is the rate of reaction for one particular enzyme is blue and one particular enzyme in red. So what would the max point be for the enzyme in blue? Right. Okay, so sorry. How would we figure out what the max rate of reaction would be? What would we do to measure it? We don't have numbers, but what would we do? I'll do this one for you guys. Okay, so we go over and we see what the rate.
The difference between the reactions and the products?
No. That's you're talking about the other type of graph. Okay, so what will we do to find what the max rate of reaction was for this enzyme? Okay, so what can we say about the max rates of reaction for these 2 enzymes?
They have different max.
The red enzyme has a higher max rate of reaction than the blue enzyme. Okay, what other piece of information will we compare the 2 rates of reactions? So we just did the rate of reaction, how they compare, and now we won't say acidity. We say pH level because basically if it's below 7, we say that's acidic. Okay, so again, we just do the same thing. All right, what can you tell me about the max for the blue enzyme?
That's more acidic.
It happens at an acidic spot, and the max is basic. And then again, I did draw some lines in there, so you can't actually estimate. This is somewhere between 5 and 7, right? So let's say that this is again, this was a terrible graph, but let's say its max is a pH of 5,
Mm-hmm.
and let's say here the max pH is 9.
Mm-hmm.
Okay, so pH of 5, pH of 9. And then, so what would you say about the max of this one is acidic, you said? The max of this one is basic, you said? Okay, so remember when we talk about enzymes, at the max, that's the optimal, right? What is it about an enzyme that makes that optimal?
What do you mean?
Why does an enzyme reach a maximum rate of reaction? It's in its, it unravels
Once it reaches a
beyond,
certain temperature?
well, we're not talking temperature, we're
When
talking
it reaches a
pH.
certain pH level?
It, when it reaches a certain pH level, it works best. What can we say about the pH at that point?
It's basic.
In this case, it's basic. In this case, it's acidic.
But aren't you
So
talking-
just overall, for any enzyme, when we see the max, what can we say is happening there?
That's the highest it can go.
the pH level.
So it can go lower or higher and not be as good. It's max there, but why? What do we know about
More effective?
enzyme?